Okay, so today we're going to be working on lesson 13, dividing multi-digit numbers using the algorithm. So with the algorithm, we're just going to use standard division. Our first problem, example 1, is divide 70,072 divided by 19. We are going to go ahead and skip part A on these problems. We're going to skip past the estimation portion of this. We're going to skip to part B, where it asks us to create a table to show the multiples of 19. Now the reason that we're going to do this is because 19 is not a very friendly number. So a good strategy is to create this table of values to show the multiples of 19. This way when we go to divide, you'll know what the multiples of 19 are. It'll make it easier to complete the standard algorithm. So we're going to make a list of multiples from 1 to 9. So we're going to do 1 times 19 is 19. 2 times 19 is 38. Now, some of these are not going to be right off, you're not going to be able to get them right off the top of your head. These are not basic math facts. We can think of multiplication as repeated addition. So 19 times 1 is always going to be 19. To get 19 times 2, you can multiply by 2, or you can just add 19. So each time, we are just adding 19. So when we do 3 times 19, you can either do the multiplication to get 57, or from 38, you can add another 19. You'll still get 57. Choose the way that works best for you when you're filling out these multiples of tables. 4 times 19 is 76. Again, we could have added 19 to 57. 5 times 19 is 95. 6 times 19 is 114. 7 times 19, 133. 8 times 19 is 152, and 9 times 19 is 171. So now that we have this table filled out, you can flip to the next page. Scoot that one off to the side. They've actually written the problem out for us. We still have the problem 7,072 divided by 19, and they've went ahead and written it in standard algorithm for us. Remember, the first number is the dividend, and this number goes inside the house, if you consider the division sign a house, and the 19 is the divisor, and it goes outside the house. 7,072 divided by 19. So here we have to ask ourselves, this should not be anything new, this should definitely be a review. You guys have learned division, practice division. I know you did this last year, I'm not sure, you probably also did it in 4th grade. These numbers are just a lot bigger. Again, we're using big 6th grade numbers. So we ask ourselves, can 19 go into 7? We know it can't. So we move on. Can 19 go into 70? Well, if we look at our multiples of 19 page that we made, 19 can go into 70 3 times. And we know that because 19 times 3 is 57, but if you go up to 19 times 4, that's over 70. We have 76. So we want to know how many times 19 can go into 70 without going over. So we know it's 3 times. So because we're putting 19 inside 70, we have to put that 3 above the whole number 70. It can't go in this first space because it's not going inside 7. It has to go here because it's going inside the number 70. So then we multiply it out. 3 times 19 was 57. And now we subtract. And we get 13. We can't put 19 inside of 13, so we bring the next digit down, which is a 0. Can we put 19 inside 130? Again, let's go over to our multiples table. We want to go into 130 without going over. If we go to the 7 times 19, we go over 130. So we're going to say it goes in there 6 times. Again, you put it above the next place value. 6 times 19 on our chart was 114. Subtract that from the 130. And you have to borrow and regroup. 10 minus 4 is 6. 2 minus 1 is 1. 1 minus 1 is 0. Again, bring down that next place value. Now we have 167. Flip back to your multiples of 19 chart. How many times can 19 go into 167 without going over? The closest we can get is 152 with multiplying by 8. So it's going to go in there 8 times. 8 times 19 is 152. When we subtract that, we get 15. And if we bring down our very last place value, we get 152. How many times can 19 go into 152? And if we switch back over to the multiples of 19 chart, we know that 19 can go into 152 exactly 8 times. We put our last 8 up here. 8 times 19 is 152, and we subtract, we get 0, with 0 remainder. Now that every place value until the end of the dividend is filled, we know 3,688 is our answer. The directions do say to check your work. If you want to check your work on a division problem, you work backwards and multiply. We would take the quotient, which is the answer to the division problem. We would take the quotient and multiply by the divisor. We should end up back with the dividend. 3,688 times the number 19. Go ahead and multiply that out. 72 plus 7 is 79. 9 times 6 is 54. 61. 27 and 6. 33. Cross those out. We're done. Put our 0. 8. 8. 6. 3. Add those together. 10, 10, 7. We have 70,072, which matches our original problem. So this is the whole process for dividing multi-digit numbers using the algorithm. Our first step was to make a multiples table to make that dividing just a little bit easier. Next was to write the problem and then go ahead and solve it like we would any multiplication or division problem, excuse me. When you go to check your answer, you take the quotient times the dividend to get the divisor. Let's go ahead and move to example 2. In example 2, the problem is 14,175 divided by 315. So in this case, before we get started, we're going to make a multiples chart with multiples of 315. So 1 times 315 is 315. 2 times 315 is 630. Again, you can use your multiplication, or you can simply add 315 each time. Choose the way that works best for you. 3 times 315 is 945. Again, same as 630 plus 315. 4 times 315 is 1,260. 5 times 315 is 1,575. And I'm going to stop there. That's a pretty big number. If I need to go farther when I get into the problem, I can always go back to my multiples table and continue on from there. Next step is to write the problem. So the dividend, 14,175 goes in the house. We're going to divide that by 315. 315 can't go into 1. 315 can't go into 14. 315 can't go into 141. 315 goes into 1,417. So now we're 4 place values in. So our answer is going to sit above the 7 in the quotient. How many times can 315 go inside 1,417 without going over? So let's go to our table. We want it to not go over 1,417.